In number 73 from section 5.2, it's a word problem on art and mathematics. And it says, when working in 2-point geometric perspective, artists must scale their work to fit on a paper or canvas they are using. In doing so, they use this equation, a over b equals tangent of theta divided by tangent of 90 degrees minus theta. Rewrite this expression on the right in terms of sine and cosine, and then use the difference identities to show that the equation can be rewritten as a over b equals tangent squared. So I'm going to leave that down in the bottom right hand corner. That is our goal, to get to that. So working with the equation here, we have tan of theta, that in the directions here were to convert it to sines and cosines. So I'm going to change that to sine of theta over cosine of theta, all over sine of 90 degrees minus theta over cosine of 90 degrees minus theta. So looking at that denominator, I'm gonna the numerator I really can't do anything with. It's as simple as it gets. But the denominator, I can apply the difference identity. So I will do that with sine and cosine. So that would be sine of 90 degrees times cosine of theta degrees minus cosine of 90 degrees times sine of theta degrees over cosine of 90 degrees times cosine of theta degrees minus, plus, we use a different sign for cosine, sine of 90 degrees times sine of theta degrees. So that's our numerator. So I'm actually going to move our fraction bar left a little so that I can rewrite this equal sign here. I didn't do anything to the numerator, but just to be consistent, I don't want to lose that information, so I'm just going to copy it over. But I still have this big fraction bar, so that entire fraction in the denominator there is still in the denominator. Alright, so now let's continue to simplify that. So again, I'm just going to copy our old numerator of sine over cosine, because I'm not doing anything with that yet. But I'm going to simplify that second part, this guy right here. So let's see, sine of 90 degrees. Think about your unit circle. At 90 degrees, we're right about here. And the sine is the y value. So sine of 90 degrees is 1. And the cosine of theta, I don't know what theta is, so that's just cosine of theta, minus cosine of 90 degrees. So again, thinking about your unit circle being right there, the cosine is the x value, so that is 0. And 0 times anything, including sine of theta, is still 0, so I'll just leave that as 0. Actually, I'll go ahead and just write it in just to show my work, but in the next step we'll write it as 0. And in the numerator of the numerator, we get cosine of 90 degrees is 0 times cosine of theta plus sine of 90 degrees is 1 times sine of theta. Okay, simplifying to our next line, the top I'm just going to copy down again. I didn't do anything with this sine or over cosine yet. Over, and in the purple, simplifying that a step further, 1 times cosine is just going to be cosine. 0 times sine is 0. Over 0 times cosine is 0. And then 1 times sine of theta is sine. So I've now simplified to that. I'm going to shorten this fraction bar so I have some space. And this, so now I have Let's break it up into division. So if I divide by cosine over sine, that means flip the second and multiply. So I'm going to multiply by sine over cosine. Well, that is just tangent times tangent, which equals tangent squared. So that is the final product.